Okay, our topic today is applying algebra. Now, math teachers hear one question probably as much or more than any other question, and that is, what am I ever going to use this for? Sometimes it's done just to delay things, but sometimes it's an honest question. Algebra is actually a really effective tool for an awful lot of things in the real world. For example, when I was practicing law, which you may know I did for several years before teaching, when I was practicing law, I actually used algebra quite frequently to figure out the most appropriate number that was relevant to something that a client of mine needed to do. Used it quite frequently, almost every day. Now, let me give you an example. When we talk about, by the way, when we talk about applying algebra and applying it to real circumstances, what we're talking about is a process called modeling. Algebraic modeling means that we are looking at a real-world situation and we are reducing it down to an algebraic expression so that we can solve it mathematically. Let's say, for example, that we have three people that were going to a carnival. Let's call them Alex and Byron and Calvin. Okay? Alex, Byron, and Calvin are going to a carnival. Alex says, well, the carnival gives him three choices. And one of the choices is that you can get a $50 ticket, you pay $50 to get in, and then you can ride all the rides for free. So Alex is going to choose that. Alex is going to choose the flat deal of $50. That's how much he's going to pay. Byron takes the second choice. The second choice says it costs $20 to get in, and then every ride you ride costs $2. So Byron, now what we're going to do, because it's always important when we're doing algebraic modeling or applying algebra in this way, is we have to define what our pronumerals or our variables are about. So in this case, what we're going to do is we're going to say x equals the number of rides. X is the number of rides. So Byron is going to pay $20 to get into the door and then $2 for each ride that he rides. How much is he going to pay for the day? He's going to pay $20 plus $2 times the number of rides that he rides, or 2x. Now Calvin, on the other hand, decides that he wants the third option. And the third option is that you pay nothing to get in the door, to get into the carnival, but every ride in the carnival costs $5. So he's not going to have this part of the expression, but he will have this part, except for him, how much does it cost? $5 for each ride, or $5 times the number of rides. $5 x, or 5x, that's how much he'll pay. Now, when you think about this, did they each choose the right choice? Well, it depends on how many rides they rode. Let's say, for example, that we find out that Alex rode 15 rides. Okay, fair enough. He paid $50. Was that his best deal? Well, let's say if he'd done what Byron did, he would have paid 2 times 15, which is $30, plus 20 would be another $50. So he would have broken about the same. But let's say Alex was a really big rider and he rode 20 rides instead. He still just paid $50. If he had taken Byron's deal, he would have paid 20 times $2 is 40 plus another 20 to get in the door. That's $60. He would have paid more. Or if he'd taken Calvin's choice, he would have paid 20 rides times $5 would be $100. So in this case, Alex has gotten the best deal. Now, Byron likes to ride rides too, not quite as much as Alex. He's only going to ride 10 rides. So how much is he going to pay? Well, he paid $20 to get in, plus $2 for each ride. That's 20, plus 2 times 10 is 20. So he's going to pay $40 for his day. Is that his best deal? Could he have done better? Well, let's see. If he'd done Alex's ticket, he would have just paid $50. That would have been more. If he had taken Calvin's route, he would have paid $5. Wouldn't have paid anything to get in the door, but he would have paid $5 for each ride. That would have been $50 as well. Both of those would have cost him more. Now Calvin over here, he brought his girlfriend along, so he didn't ride quite as many rides as the other guys because he was just kind of enjoying being with his girlfriend, and he only rode 5 rides. How much did he pay for his day? Well, he paid $5 for each ride, times 5 rides is $25. What if he'd done the other choices? Well, if he'd done Alex's choice, he would have paid $50 for his day. Wouldn't have been as good of a deal. Or if he was Byron, he would have paid $2 for each ride. That would have been $10, plus $20 to get in, which would have been $30. So he would have paid more that way as well. Now this whole process here is what we call algebraic modeling. We can use these algebraic expressions to apply real-world situations and reduce them to mathematical discussions. Now, in order to do this sort of problem, we have to figure out how those real-world scenarios can be reduced. So let's say, for sake of discussion, that we had a certain number of bottles. We had K bottles. K, if we define it, K is our number of bottles. Number of bottles. And we are told that those bottles cost $4 each. Well, if they cost $4 each, how much will it cost us to buy K bottles? Well, for each bottle it's going to cost $4. So K times the number of bottles. K times $4 a bottle, or 4K. Okay? What if I said I have a rectangle? Here's a rectangle, and it is, and it has length and breadth. Here's the length, here's the breadth, and what I know is that the breadth is X centimeters long. X, that equals the breadth. X is the breadth. The length is 2 centimeters more than the breadth. So the length is 2 centimeters more than the breadth. That means how long is the length? X plus 2. Now what if I wanted to know the area of my rectangle? Well, we know the area of a rectangle is the length times the breadth. So we take the length, which is X plus 2, and we multiply it by the breadth, which is X, so X times X plus 2. And as you know, if we wanted to expand that, we could. And we'd multiply both of those, multiply the X by both of those items, and we get X squared plus 2X. And that would be our area. Let's try a very real-world situation. Let's say you've got a broken pipe at home, so you call the plumber. And the plumber says, well, here's what it's going to cost you for me to fix it. It's going to cost a $40 call-out fee. In other words, he gets out of his truck at your house, it's going to cost $40. Plus, it's going to cost another $70 per hour. Now, how much is it going to cost to hire the plumber? What's it dependent on? It depends on how many hours that he works. So we're going to call N the number of hours. N, remember we have to define our pronumerals or our variables. N equals the number of hours. How do we express the cost that it's going to cost us to hire our plumber? Well, it's going to cost $40 just for him to show up, plus what? It's going to cost $70 for each hour. And we're going to do it for N hours, so we want 70 times the number of hours, or 70 times N. That gives me $70 times N, or 70N. That's how we do applying algebra problems. That's all.